Welcome back. So now we're going to be talking about if statements. If statements are something that's really, without if statements, you probably wouldn't have much of a program because all programs have to do some processing and they have to make certain decisions. If they're not making decisions, then they may not be doing much. Now, there's possibility, there's exceptions to everything, but you're going to have if statements. So let's talk about if statements. So if statements take the form of you write an if statement, right? So let's take, for example, let's say we take the variable x. We take x equals 5 and y equals 10. And we can write several statements. So we can say something like if x equals 5, and we can say printf x equals 5, right? And we can run this and you'll see that it prints. Oh, and let's not forget this. Let's do something interesting. No, let's leave it like this. Okay. So x equals 5. And now we could also say if x greater than 3, printf x greater than 3. And we know that x is greater than 3. So we run this and you see that it says x greater than 3. So we have that. We could also say if x not equal, this is not equal, this is the operator for not equal to 10, printf x not equal to 10. And I think you'll see a recurring pattern here. The if statement has to execute true for the conditions. So as long as it executes true, if x is equal to 5, well, that's a true statement. So it does what's inside of the if statement. Now, the if statement takes this form, this syntax. You have to write if, and you have to have enclosure in parentheses, where you have the parentheses there and the parentheses here, right? And then the statement here. Now, in order for the if statement to execute, it has to be true. And now sometimes you could say different things. You could say, for example, like in this case, not equal to 10. Well, that's also true. Or you could say, if um, x is equal, greater than or equal to, because you have several different ones. So several different operators. So for example, we can just go all day like this. We could say if x greater than or equal to 5, so it's not greater than, but it is equal to, so that's a way of saying greater than or equal to 5, x is greater than or equal to 5. And we run this and we know that it is greater than or equal to 5. One thing that I keep forgetting is my new line escape sequence. Let's run it again and see. So now you see x equals to 5, x greater than 3, x not equal to 10, x. All those statements are true. So I made it so that statements are true. What happens when it's false? For example, if I say if x greater than or equal to 6. Well, that statement is going to evaluate to false because x is not greater. In other words, x is holding 5, and x is not greater than or equal to 6. It's not greater than, certainly, and it's not equal to 6. So, and we could still put the statement there to handle it, but as you see, it's not going to print out that statement. So the operators, let me just comment the operators here. The operators, the comparison, so you have the equality, we saw that. You have the not equal to, we saw that. We have the greater than, we have the less than, we have greater than or equal to, less than or equal to. Okay, and which one are we missing? So we have equal, not equal, greater, less than, greater than or equal to, less than or equal to. Okay, and so those are our operators. Now, as you can see, really any statement that evaluates here. Now, let's do something interesting with the if statement. And C is kind of interesting about that because, for example, if we say if, and let's just say something like this, if 0, printf, what the heck? Okay, will it execute? Let's take a look. Oh, let's not forget our new line character. And then print anything. Okay, x0. Okay, well, what if we put a 1 there? But, you know, it didn't give us a compiler error, so, ooh, look at that. If it's 1, oh, well, that's not an evaluation. What if I put 4? Ooh, it executes also. Notice that it prints out what the heck. So what if we did -1? Ooh, it still outputs that. And so I point this out for something very important. And you notice that I'm doing what I'm doing with a lot of these, right? So let's say, for example, x is equal to 5. What if we did something like this? What if we said x is equal to 21? We know we don't even have that number. What if we do this? What's wrong with that? Ooh, and we'll say x equals 21. Let's change this. Run it. Ooh, but x is not equal to 21. What happened here? Well, this is valid syntax in C. Some other languages don't let you do that, but this is saying if x assigning 21 to x, and then it captures the value, so it's just saying if 21, and it'll print that out. So one trick that many C programmers, experienced C programmers will do is they don't ever write the literal on that side. They actually write it on the other side. So for example, they'll say if x equals 21, which won't execute. But what if we said we made the mistake? We have a mistake, you know, just we forgot to put in the other equals. Well, we get a compiler. So that's kind of a safety check, safety mechanism because it's easy to assign. So the if statement, anything that's non-zero, right, will evaluate to true and it'll execute. So you have to be careful about the if statement. So we cover the if statement. But for evaluations, there's more to it than that. So we can say we can combine some of these and we can combine these statements. So for example, when we say here, if x greater than or equal to 6, we could say if x is greater than 6, right? Greater than 6, which we know is not, or, and we can combine like another, or y equals 10, for example. If we say that, will this execute? Well, this is your OR operator. I know it looks weird. it should be the word or maybe, right? But no, C is not like that. So this two pipe characters, that's your or statement. So if x greater than 6, well, this is false, but this is true. So it's either if this or this. So this is false, but this is true. So this is going to execute. And we could say, and now we can run it. And you can see, okay, well, let's not do that. Oh, yeah, we still have this error over here, so we should do this for that, just to take care of that for now. So it evaluated. Now you can combine as many of these as you want. And sometimes if you have like complex pieces, you may actually want to surround them with parentheses. It gets really confusing to read some of that. You may not want to introduce that level of complexity, but if you have to, then I guess that's what you have to do. But typically you don't want to get too big with it, but you can combine them. And there's another one that you can say and to join them and say if x greater than 6 and y equals 10. So, but that's not going to evaluate. So we say if x equals 5 and y equals 10. If x equals 5 and y equals 10, and this is for these, in this case, both of the statements have to evaluate to true. So this has to be true and this has to be true. If one of them is false, it will not execute. So let's run it. So it runs x equals 5. Now what happens if I said if x equals 6 or 7 or something and y equals 10? Well, it won't execute. So it won't execute. So you can see where you can join these together and come up with some really complex logic. Now another thing to keep in mind is that once, depending on the order, if you have, for example, x equals 7 and y, it's going to evaluate this, and if it sees an and, then it's going to have to, if this is true, right? If this is true, then it'll go and evaluate the second piece of the statement. But if this is false, then it just stops right there. It doesn't even go any further. And that may be important in the case where maybe you put your most frequent evaluation, something that'll be false first. So that way your if statements fail first and it's less processing and everything. So let's say, for example, if you said, let's say you have a, you know, let's say you're at a grocery store and you happen to sell some kitchen utensils. And in the case you might say if it's kitchen utensil and is seasonal product, or if it's kitchen utensil and if it's kitchen utensil is and it's a certain price or something, or greater than a certain price or less than a certain price. Well, you may not want to do the kitchen utensil first, or maybe you do. Maybe that, because that evaluates the fault because nothing is kitchen utensil. So maybe you want to do that first. So you just got to take that into consideration. So you can join them that way. And of course, you can combine the greater than or equal to, not equal to. There's something common that you may want to say, for example, like let's say, for example, x8, you want to omit something, right? So let's say, for example, you use the not operator. You say if x not equal to a certain value, you want to exclude anything that's 7 and anything that's, let's go back to x, not equal to 10. So maybe you have something where you don't allow 7-year-olds. You just discriminate because you don't want 7-year-olds and you don't want 10-year-olds because they're worse, right? Or maybe you don't want 7th graders and you don't want 4th graders because they're both immature. 7th graders are immature because they're just the first year of middle school, and then you don't want fourth graders because they're immature. You only want sixth graders and eighth graders, right? So maybe you don't want, fourth graders, and you don't want seventh graders, and you'll take all the grades because first graders, second graders, third graders, they're lovely. Fifth graders, sixth graders, they're lovely, and eighth graders, they're mature and they don't misbehave. But you discriminate against all fourth graders and seventh graders. So the way you do that is you would have to say not equal 4 and not equal 7. That's one way of doing it. This is very common to do, and it trips up a lot of people because a lot of times people will think that they have to do, uh, you know, that they have to do or if x not equal 4 or x not equal 7. Well, if I do this, everything will always evaluate because why? When it's 4, right? It's going to say x not equal to 4. Okay, well, that's false. That's actually a true statement. X not equal to 4. So then it's equal to 4. So that's a false statement. But then it's going to look at the or and it's going to say or x not equal to 7. Well, 4 is not equal to 7, so it evaluates. So it's important that you do that. And there's tricks to get around that. For example, you might actually say, instead of doing it like we're doing it, you could say x equal 4 or 7. Okay, well, you got here, now you got x equal 4 or x equal 7. Well, you don't want these guys. So what you do is you say not 4 or 7, right? I think that'll work. So let's see if it works. And that's one thing that I didn't cover. So if x not equal 4 and not 7, so what if we did 5, for example, since x not equal 5 or 7, right? So it doesn't execute. What if we change x to 7? Because it wants to omit 7, and it omits it as well. So just something to keep in mind. This is if statements. I know the video's gone a little long. We haven't. Another thing I want to show you, and it kind of follows along, is that for if, right? So like these if statements are independent. Like this is going to execute and then do something with it, and that could execute. And then this one could also be true. Now ignore the fact that they do. But if I did something like this instead, if I said else if, then it's either gonna be this or this, but not both. It'll evaluate that one. If that evaluates the true, then it won't do this one. So if this is true, execute this. Else, if it's false, and this is true, then it'll execute. It might not execute either one of them. But you also have one more where you have the else. So you can have the else. You don't need an else if for an else. You can actually do the else at the end and maybe catch everything else. And this will, if this is false and this is false, then the else will execute. So you have that. So for example, this in this case, it's either going to be this. This is always going to execute. So like in this case, since I put a hardwired -1, it's always going to execute this. It'll never reach here and never reach here. So if I was to say it'll never reach that. It'll always be in what the heck. But what if I said 0? Okay, so now I'm in the else because 21 is not equal to x. So it fell all the way into the else. So just keep that in mind. You have if, and else, and the same thing. And one thing about it is, I'm not sure that I talked about it, but actually you can have multiple statements inside of an if. So I could actually have a whole bunch of code, a whole bunch of printf statements. I can even have other if statements inside of here that also do some evaluation. I can nest if statements. So just keep that in mind, because for example, I can say if 0, and then I can say if, something else, some other condition, and if else, and I can nest them as far. It's not good practice to do a lot of nesting. But if you have to do it, you know, 1 or 2 levels, that's fine. But when you start going beyond that, then you should really consider, you know, um, restructuring your code so that you don't have all of nested if statements. And so that's really it as far as if statements. You can play around with them and see what you think. Thanks for watching.